Morning, ladies and gentlemen. We're on Chapter 4, Section 2, Day 1. We will be talking about end behaviors for polynomial functions is the big goal for today. As we go through today, your goal, no, not your goal, but what you're supposed to do is finish watching this video for Day 1, okay? And video lesson for Group B and virtual students that are in class. Obviously, they're getting this live. There is no homework for today. Just want you to know. Tomorrow's Thursday, and we have live office hours tomorrow, so everybody's expected to check in virtually tomorrow. And what you're actually just going to have to do tomorrow is you can ask questions when you check in, but the goal will be complete page 2 of this packet, the page right after where we stop off today, and problems 1 through 3 of the Try on Your Own, and we will finish day 2 of the lesson on probably Monday, and then you'll be able to finish that up. So, as we're moving along here, we have a long warm-up problem here, and basically want to point out you've studied linear functions and quadratic functions. Now we're going to explore more polynomial functions. Now a quadratic function, is a polynomial function. It's right there. It's one of. There's an infinite number of polynomial functions, okay? And a common type of polynomial function is called a power function, okay? And a power function is a function of the form p of x, some number a, x raised to any power, n is a non-negative integer, because as soon as that exponent is negative, we're into a rational function, no longer a polynomial function. So, but just so you know, for the purpose of today's lesson, we're only going to focus on power functions right now in the very beginning where the a value is 1. Okay, and as we get deeper into the lesson, we'll have a couple a values that are different than positive 1, but we'll identify that when it comes. In the next section, we'll investigate power functions with various a values, which we have a few today. So consider these next 6 functions that you have here. Y equals x squared, y equals x cubed, y equals x to the 4th, y equals x to the 5th, y equals x to the 6th. Study the pattern that these graphs are going through, okay? Look at them. You see it goes from one to the next, to the next, to the next, and then just kind of take a gander at that. And what we want to do is I want you to sketch and label the next 2 graphs in the sequence where one of them, the next one, is y equals x to the 7th, and then the one after that is going to be y equals x to the 8th, okay? Make a sketch based on the patterns going before, okay? Can you make an educated guess of what y equals x to the 7th looks like? Hopefully, my smartboard is not working for me very well today. You see all those functions are going through 0, so this is going to kind of come up and it's going to kind of come down. And actually, if I drew this appropriately, as you're watching the patterning that's happening, what's happening right here at 0, this is getting flatter and then goes up super steep and then super steep. Okay? What does the x to the 8th power do? Well, that's going through 0 and that's kind of flatter and then it spikes up and it's flatter and it spikes up. Now it doesn't go vertical, it's just growing super fast, okay? Based on the observations or patterns that you noticed about the graphs in the sequence, okay? What observations did you make, okay? There's a couple key observations that you were supposed to see. First of all, if the degree is odd, the function points in opposite directions. That means the right side of the function is going in opposite direction as the left side of the function. Kind of like my x to the 7th. The right side's going up, the left side's going down, okay? Even. If the degree is even, and when we're talking degree, 7's an odd number, that's an x to an odd degree. Even degree, x to an even degree. If you look at all of them above, anything with an even power, the function points in the same direction on the right side and on the left side. They're both going up, okay? Well, that's a huge observation to make. Then we're going to make a general statement about the graph of a power function raised to an odd degree. Okay? General statement would be they move up from the left and to the right, and then they continue up. Meaning they're coming from the left side, they're continuing up. They got a little squiggle, and then they keep going up like that. Okay? How's about another observation? Just restating basically what we said in part B. Arrows are pointing in opposite directions, okay? Well, what's the next question got for us there? A general statement about a power function raised to an even degree. Well, hopefully you saw all of those even degrees were concave up. They were upward opening parabola looking critters. However, please make note right here, right now, the ones we looked at, A was positive 1 on every one of them. Remember what happened if A was positive in a parabola? It opened up. What happened if A was negative? I wonder what happened then. Yep, that's right. It went downward. Okay, bottom line. Arrows pointed in the same direction for our even degreed functions. Okay, this is going to take us to our next page here. What is called the end behavior of a graph of a function is the behavior of the graph as x approaches infinity and x approaches negative infinity. What does that mean? Well, you can write the end behavior of this polynomial function using the following notation. In this notation, the further in math you get, the more comfortable you need to be with it, okay? In math, okay, we use lots of symbols so we don't have to write long sentences and such. So what this means is, in the beginning right here, as x approaches infinity, okay, what that really means is as x is going right. So as x approaches infinity, way out here on the right side, where is my f of x? That's just another name for y. Where is my y going? My y is going up to here to infinity. Okay, that's what that arrow means. I'm going on forever. As x approaches negative infinity. Okay, that's a math way to say left, because from the origin here, if I go left, I go to negative infinity when I get way down on the end of that number line. Where is my y value going? My y value is going, in this case, to negative infinity, meaning down. Okay? Negative infinity is down here, and that's what that arrow means. I'm going down. So explain in words, okay? This notation is very, very important. Explain in words what the end behavior in the worked example means, okay? So, as x approaches infinity, one way to think of it is, as x gets very, very large, because that's what this is, as x goes x values get very, very large, and they're positive, okay? F of x gets very, very large, and notice that's a positive infinity, meaning it goes up. Another way that makes more sense to people is as x goes, because this is a positive infinity, again, I'm hitting out here, as x goes to the right, the y values go up because this is also a positive infinity. Okay? Well, what does the next one mean there? As x approaches negative infinity. Well, that means as x values get very, very large negatively, the y values get very, very large negatively, okay? Because as I get very, very large to the left, I get very, very large negative numbers. The graph goes down, meaning I get very, very large negative numbers for y, okay? The way I like to think about it is, as x goes to the left, negative infinity is a way to say when we're talking about x, a negative infinity is left side of the graph, okay? Remember, here's 0, 0. As I go left, that's negative infinity. Y, that's another name for y, negative infinity, means down. And up here, as x goes to positive infinity, I like to think of that as the right, y goes up, or to positive infinity, meaning going up, okay? That's really what it means. I like the bottom of these two. X goes right, y goes up, x goes left, y goes down. Now, how do we identify these patterns in here? Well, what we're going to do is hopefully you're going to take Desmos, okay, and I'm going to hit pause here for a second, and I would like you to graph these four functions to the best of your ability. Just graph them in Desmos and copy the graphs to your paper and see if the end behavior is affected as we put all these extra other terms in there. Does anything happen with them? Okay. Again, so as we add, this is an odd degree. See, that's a third power. The biggest power is third power. But as we add this extra stuff, that one's a third. As we add that extra stuff, does it affect the end behavior? Meaning, well, let's check it out. Well, let's look at it. Well, that's weird. It's odd degree. They're going in opposite directions. And it's odd degree, and they're going in opposite directions. But what's different about these two? Well, let's just see. Okay, so what we're saying is, as x goes to the right, to positive infinity, f of x is it going up or down? This one's going up, and when I talk up for y, that would be a positive infinity. Also, as x goes to negative infinity, that's talking about left. Okay, this was talking about right. Where is the y values? Where are the y values going? So as I go this way, I can see I'm going to negative infinity. Okay, well, what's different about number two? Number two, as x goes to the right, f of x goes, this one's going down. And as x goes left, f of x now goes up. Well, what's different about those two functions? No wonder. Let's check it out. How about these next two? Well, notice these are both even. Even degree. Did this other stuff affect it? Even degree, this has got a whole pile of business in there. Okay. Did that affect my end behaviors? Check it out. They're going the same way. They're going the same way. Before they were going the opposite way. But look at it. Look at number three. As x goes to the right, f of x goes up. And as x goes to the left, f of x goes up. Okay? Over here in the other one. As x goes to the right, f of x goes down. And as x goes to the left, f of x goes down on this one. Why is that? Well, let's check it out. Let's go to our next page. Well, generalizing our information. Okay, what we're going to do is I'm going to hit pause so I can fill a bunch of this stuff out and save time in the video. Before we fill these in, let's come right back to this previous page here again. And what I want to do is I'm going to clear all my ink on here a second. Come on, baby. Clear it. And what I want you to focus on is two things. First of all, this is an odd degree. Odd degree. Even. Even. Okay? So, what do I notice is the same in my A here is a positive A and the positive A here. Here my A is a negative value. Here my A is a negative value. Okay? What do you notice happens for both even? Where are the even and the odd? Where are they the same if A is positive? What do you notice? You notice they're both going up on the right side. And check it out. What do you notice if even and odd, if A is negative, what do you notice? The right sides are both going the same direction. So check this out. Really important. If the degree is odd, as I go to the right and I have a positive coefficient, I go up. If it's even with a positive coefficient, I went up. Now, remember, odd is opposite. Odd is opposite. So that means the left side has to go opposite the right, has to be going down. Even is same. So if the right side's going up, the left side has to go up. Okay? And I can come over here. If I'm odd degree, negative coefficient, as I go to the right, I go down. The same way, if I'm even, negative coefficient, the right side goes down. Now, because this is an odd degree, remember, odd means opposite and behaviors. So if the right side is going up, the left, or if the right side's going down, the left side has to be going up. Even means same end behaviors. So if the right side's going down, the left side has to go down. Okay? When they're talking examples of a function, give me an example of a function that's odd with a positive lead coefficient. It really doesn't matter what else I have in here, because when I'm looking at end behaviors, I am solely looking at this guy right here. Nothing else matters. So I could just use that for my example. And here, an example of a function that's odd with a negative, well, let's get really creative here. Plus, don't really care what comes after that, because my end behaviors will be dictated off of my largest power of x with its a value, okay? Same thing over here. When I'm doing an example of a function that's even and positive, don't really care what comes after it. Even and negative. I'll get crafty. I'll put a 3 on that one. And I don't care what comes after it, because all I'm doing is a value determines the right side. Okay? If A is positive, it goes up, meaning infinity. And if A is negative, it goes down. And down in math means negative infinity. Okay? So the A value dictates the right side. Okay? The degree determines the left side, because if it's odd degree, it's opposite the right. If it's even degree, same as right. Okay, really important there. And this last little bit here is really not too much to talk about. It's just as x goes to the left, f of x goes where? We're just dictating what does this mean? Well, all that means is as x goes to the left, f of x goes question mark, then y goes up or down question mark. And this shorthand is just much easier to write that you need to get a hold of. Okay, that's it for today. No homework for tonight. See you tomorrow.